Today we're going to look at equations of lines. So first of all, we have a few different ways that we can leave the equation of a line. The first one mentioned here is general form, when the equation is in the form ax plus by plus c equals 0. So everything is on the left-hand side of the equation. The a, the b, and the c are all whole numbers where possible, and the a in front of the x is a positive coefficient. The next form that we have is gradient form, which is our y equals mx plus b. This form is useful because we can read off our gradient, which is m, and our y-intercept, which is b, straight from the equation. Next, the vertical form of a straight line is when we have x equals to some number. So I just put an a in there, x equals a. So it could be x equals 2, which would be a vertical line going through the 2. A horizontal line is when the equation is in the form y is equal to a number. And the last one that mentioned here is the intercept form. If the equation is written in this manner, so x over a plus y over b equals 1, then the a will be the x-intercept and the b will be the y-intercept respectively. Okay, so let's jump into the questions. Number 1, find the gradient and the y-intercept of the following linear equation. So it's y equals 5x minus 11. It's in gradient form, which means that the gradient, the m, is the number in front of the x, so that's 5. And the y-intercept, which we give the symbol b, is the number on the end, which is negative 11. And that's it. Part B, find the equation of a line that passes through the point 0, 3 that is parallel to y equals 5x minus 11. So we already know that the gradient of this line is 5. And I've been given a point, but this point is a special point, the point 0, 3. If the x is 0, that means that the 3 is the y-intercept, which we give the letter b. And that means that I can write down the equation of the line using my y equals mx plus b form. So m is 5, so it'll be 5x plus 3. Part C, find the equation of a line through the point 0, 3 that is perpendicular to y equals 5x minus 11. So again, my gradient from that equation is 5, but I'm going to call that m1 because this time I want to find the gradient that is perpendicular to that, which means I want to find the second gradient. Now we know that the two gradients have to times together to give negative 1, or we had a second formula, which was m2 equals minus 1 over m1. In other words, the negative reciprocal of the first fraction, the first gradient, sorry. So if I sub in the m1, that's minus 1 over 5. I want to use that perpendicular gradient and the point, again, because it's a 0, that 3 is my y-intercept. And I can put that into my y equals mx plus b. So that is y equals minus 1/5 x plus 3. Question 2. Find the gradient and y-intercept of 2x plus 5y minus 10. Well, that's in general form, so I need to turn that into gradient form. So I want the y to be positive, and it currently is positive. So let's move everything else across to the other side. So I'm going to leave the 5y equals, it'll become a minus 2x and a plus 10 when they're moved across to the other side of the equation. Now I can divide each term by 5, which would give me negative 2 over 5x, and 10 divided by 5 is 2. And we're in gradient form. So that means that the gradient is going to be the negative 2 over 5, and the y-intercept is the plus 2 on the end. Okay, on the next page, question 3. Find in general form, the equation of a straight line that passes through the point 0 minus 5 that is perpendicular to a line with gradient 3 over 5. So again, we're doing perpendicular. So the gradient that I've been given is going to be my m1. That's 3 over 5. The perpendicular gradient, the m2, I need to do minus 1 over m1, which is minus 1 over 3/5. Now, 1 over any fraction turns the fraction upside down to become 5 over 3, and it's negative now. So I want to use this gradient, the perpendicular gradient, and I want to use my point, which is up here. Now, just for something different, that minus 5 would be my y-intercept, and I could put that into my y equals mx plus b form. But just as a little reminder, I want to remind you of this other formula that we have, which is y minus y1 equals mx minus x1. That's the point gradient formula that we can use for any point and any gradient when we don't have the y-intercept. So let's use that formula this time. So that will be x1 for the 0, y1 for the minus 5. Subbing that in, we get y minus minus 5, so that becomes a plus 5. And that equals m, which is minus 5 over 3, x take away 0. So x take away 0 is just x. So we're going to have y minus 5 equals minus 5 over 3x. If I was trying to get gradient form, all I would need to do is add the minus 5 there. I want a plus 5 across to the other side. But the question did ask me for the general form of the equation, which means I want xy constant equals 0. So I want my x term over here not to have any fraction in it, so I need to times that 3 away, and I'll also need to make it positive. But timesing the 3 first. Across the other side, that's going to make 3y and minus 15 equals minus 5x, because I've times the 3 away. Then, because I want the x to be positive, the x term to be positive, I'm going to move that whole term across to the left-hand side to become a positive 5x with the plus 3y and the minus 15 that was already there. And that is now in general form. Question 4. Find in general form the equation of a line passing through the point 0, minus 5 that has an angle of inclination of 60 degrees. So if we have an angle of inclination, we know that we can use our formula m equals tan theta that we learnt about last lesson. Our angle is 60, so tan of 60. Because we're trying to find the equation of a line, we definitely do not want to go to a decimal here. We want to find that exactly, and you'll use your exact value triangle, which is on your formula sheet, so you don't have to have it memorized. Tan of 60 is opposite over adjacent, which is root 3 over 1, or just root 3. So I want to use that gradient, and I want to use this point over here. It's 0 minus 5, so we can just take that minus 5 as our b value again, and we can put that into our y equals mx plus b. We're going back to the shorter method of doing it. So that will be y equals root 3x minus 5. However, the question did ask for my equation in general form, so I need to have my x first and positive. Okay, it's currently positive where it is, so let's start with root 3x. Then I'll need to move my y across to be after that, so minus y, and then I'll also have the minus 5 equals 0, and that is now in general form. Okay, that enables you to do exercise 7C.